we conclude the static tests with ray and oriented bounding box collision detection. A ray is a mathematical construct. It is represented with a point of origin and a vector for direction. Oriented bounding boxes are good for representing objects that are roughly rectangular. They are represented with a trio of axes, one for each of the three spatial dimensions, an array for storing half the length of each dimension and its position. An oriented bounding box can also be represented by a set of 6 intersecting planes. The interior volume demarcated by them defines the box. The is-ray intersecting oriented bounding box function takes in origin and direction vectors arguments for the ray. In addition, we pass in the oriented box and an intersection point to be written too. We iterate through each plane of the box and see if it is intersecting the ray. The is-ray intersecting plane function has been explained in the prior video. Please check it out for a thorough explanation. If the ray is intersecting with the plane, we test whether the intersection is within the Voronoi region, which is the box's face. A Voronoi region of a feature, vertex, edge, or face is the set of all points in space that are closer to that feature than to any other feature of the shape. We demarcate this Voronoi region by calculating two edges from the first vertex, vertex 0 to vertex 1, and vertex 0 to vertex 3. We then calculate a distance vector by subtracting vertex 0 from the intersection point of the ray into the plane. We project this distance vector onto each edge to get the square of their distances from the intersection point. This is computationally cheaper than getting their actual distances because it avoids the square root function. We then get the square lengths of the edges to compare to the projections of the edges onto the distance. If these projections are more than or equal to 0 and less or equal to the square lengths of the edges, the intersection point lies within the face of the box. In the next video, I will begin to explain collision detection for objects with velocity. Thank you for watching.